Today we are going to use our techniques of changing either fractions to decimals or decimals to fractions to compare these rational numbers. So let's take a look at our first one here, and on the first one we have two fractions. Well, since they're both fractions, let's just compare them in that form right now. And so the way we're going to end up doing it is I'm going to start with looking at the denominators and seeing if they are the same or not. And I notice that when I'm looking at the first fraction, I have 3/11ths, and over here I have 2/9. They're not the same, so I cannot compare them until the denominators are the same. So the way we're going to end up doing that is I'm going to take this 3/11ths and I'm going to multiply it by a factor that the other one has. And the other factor that it needs is a 9. 11 and 9 have no common factors, so I'm just going to use the other's denominator so I can have the same factors in this new fraction. But it'll be an equivalent fraction because when I'm looking at 9/9, that number is 1. See, 9 over 9 makes 1, and 1 times a number doesn't change the value of the number. And so let's take a look at 9 times 3 making 27. And then 9 times 11 is 99. So basically what we want to do on the next fraction is come up with a denominator of 99. And that means that we need to multiply it by 11/11ths. Now again, remember, 11 over 11 equals 1. And 1 times a number doesn't change the value of that number. And so when we go ahead and multiply it, we'll come up with an equivalent fraction, but it will look a little different. And so 22/99 is the same as 2/9. So now I can compare them. Comparing means look to see which one's bigger. And so if I look at this one has more parts, because you see how 27 parts is on top of this fraction, where here we only have 22 parts out of a total of 99 parts. And so I would say 27/99 is the larger fraction. So I'm going to draw the inequality sign open to the bigger one. Well, looking at the next problem, here we've got a decimal and a fraction. So I need to change either the decimal to a fraction or I need to change the fraction to a decimal. Now, it'll be easier to change the fraction to a decimal because if I did it the other way, I'd have to reduce the fraction as well. So, and then come up with a common denominator. So I'm going to go ahead and divide 16 into 5. Well, it doesn't go in there. That's okay. You're going to just add the 0 and over the 5 and bring the decimal point up. Add the 0 after the 5 in the dividend. And now I'm going to take the divisor and see how many times it goes into 50. So 16 goes into 50 3 times. 3 times 16 is 48, and when I do the subtraction, I end up with 2. So I'm going to continue going, and now I bring down the 0, and 16 goes into 21 times. So it leaves me with 16 left over. Do some subtraction. I've got 4 left over. So I need to extend my fraction bars bracket here and bring down that 0 and do 16 into 40. And that's going to go 2 times, making 32. And it's still not repeating and it's not terminating yet. So let's see if we can get it to terminate here or repeat. And so we'll go to 80, and 16 goes into 80 5 times evenly, and that does make 80. So we've got it to terminate. Now let's compare them. So when I compare decimals, you're looking at place values to see which one's bigger. Now, 0.31 or 31/100ths ends at 1. It terminates after the hundredths place. So what I'm going to do to compare them is add some extra zeros here, because this one has 4 significant digits, where this one only has 2. And so when I look at them, I'm going to go ahead and get that 3, this number written correctly here. It should be 3125. And I'm now going to compare place values. So I'm looking at the tenths place, 3 and 3. They're the same number. Looking at the hundredths place, 1 and 1. They're the same number. Now I move to the thousandths place, and I see this one has a 0, this one has a 2. So that tells me that the 3,125 10,000ths is going to be larger, or the 5/16ths is going to be the larger number. And so we would say that 0.31 or 31/100ths is less than 5/16ths. So let's take a look at the next one. Now we've got a fraction, mixed number here, and a decimal. So again, I think it's easier just to change these fractions into decimals. And so this is the same thing as 1 plus 4/5. So all I'm going to do is I'm going to divide 5 into 4. And I could go ahead and change this to an improper fraction and then do the division, but this will come up with the same answer. This will give me the decimal form of this fraction. So 5 goes into 4 0 times. I add the decimal point. 5 goes into 40 8 times. And that makes 40 exactly, and that terminates. So that tells me that 1 and 4/5 is the same as 1 and 8/10. Well, 1 and 8/10 is the same thing as writing 1.8. Now, which one's bigger? Well, it looks like 1.79 is bigger, but remember, we need to always compare place values. And so if I add that extra 0, it becomes more evident which one's larger. You see, 80 is bigger than 79. And if you just compare the place values, here I compare the ones place, first of all, 1 and 1, the same number. If I go to the tenths, 8 is bigger than 7. So that tells me that 1 and 8/10 is the bigger number, or 1 and 80/100. So sometimes people get confused thinking 79 is bigger than 8, but you're looking at the place value. And if it helps you, you can always add extra zeros so they have the same number of place values. Show it, and then you can determine which one's the bigger number. So we'd say 1 and 4/5 is greater than 1 and 79/100. Well, looking at our last one, we've got a decimal, and it's a repeating decimal, and then we've got this fraction. And so we can do one of two things. Again, we could change this. Well, let's go ahead and change this decimal this time into the fraction form just to compare them. And since we've done fractions to decimals so many times. But again, you could do fractions to decimals either way. So I'm going to change this 0.7 repeating into a fraction. Now remember, the way we did that is we set x equal to 0.7 repeating. Now this only has one digit repeating, so that means we're going to end up taking this number and multiplying it by just 10 to the first power. Because all we have to do is move that decimal point over one space, and then this is what we've got. 10x now equals 7.7 repeating. The whole idea is to cancel out what's repeating. So what we're going to do is use an algebra trick again. We're going to subtract 7 repeating. And I'm going to do the same thing on this side, but instead of writing 7 repeating, I'm going to write x, because x equals 7 repeating. That's what I said it was going to be. And so now I'm left with 9x equals 7. And so when I do the little algebra trick, divide by 9, we end up with the answer of x equals 7/9. Well, it looks like those two numbers are exactly the same. 7/9 equals 7/9. And so that means that we would put an equal sign in between 7 repeating and 7/9. They're the same number. Again, we could have changed the 7/9 to a decimal and come up with the exact same answer. So those are types of problems that you're going to see on tonight's homework. Good luck.